Welcome to www.notum.com. Today we'll be talking about the Pigeon Hole principle. We are Group B1. My name is Jesse Doherty, and with me is Otto Sipe, Daniel Neese, and Michael Lasky. The Pigeon Hole principle states that if there are K boxes and K plus 1 or more objects placed into those boxes, then there is at least one box containing 2 or more of those objects.
Hi, my name is Otto. I'm going to go a little bit more into detail about the Pigeon Hole principle. So the perfect way to explain the Pigeon Hole principle is with a bunch of pigeons sitting in holes. So here we have a picture of pigeons sitting in their holes. As you can see, we have 9 boxes. Now, if we have 9 boxes, we've got to figure out a way to determine how many pigeons we can have until we are guaranteed to have multiple pigeons in one box. So as you can see here, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 pigeons. So let me write that up here. 10 pigeons, right? So if we have 10 pigeons in 9 boxes, the Pigeon Hole principle states that we are guaranteed to have an overlap. So imagine here for a second that one of these pigeons, say this pigeon, is actually down here in this empty box. Draw a little beak for him, 2 little eyes. So that's our pigeon. So what that basically means is we have 10 pigeons situated in 9 separate boxes. Now, because of this, because of the Pigeon Hole principle, which states that if we have K plus 1 objects in K boxes, then we have to have at least 2 or more in one certain box. So as you can see up here, there are 2 pigeons in this box and 1 pigeon in every other box, which helps to ratify the fact that the Pigeon Hole principle helps us understand how objects are placed into certain boxes. And pigeons are great.
Hello, my name is Michael. Let's look at an example problem where we try to find the amount of people it takes to have in a room where you can guarantee that 2 people have the same birthday. Now, to start out, we know there's 366 days in a calendar year. Now let's pretend those days equal 366 boxes that need to be filled. Draw a little box, shade it in. Alright, so give an example of, let's say you have 100 people in a room. Can you guarantee that those 100 people have this, or 2 of those 100 people will have the same birthday? And we can think about it. So 100 people, let's say everyone has their own box, which is possible because you have 366 boxes, 100 people, you can have up to 266 empty boxes left over, which means that everyone can have a unique birthday, and you cannot guarantee that 2 people have the same. Okay, so let's say now that we have more than 366 people. When this happens, when you have more than 366, then 2 people are going to be forced to share a box, which means that 2 people are going to be forced to have their birthday on the same day, and you can guarantee that happens. This brings us to what's known as the Generalized Pigeon Hole principle. Generalized Pigeon Hole principle states that given n objects and k boxes, you can guarantee that there is a box with at least ceiling n over k objects in it. So, back to our birthday problem, in the case where we had 100 people, you would have had ceiling 100 over 366, which equals 1. So that means you can only guarantee there's 1 person per box. But when you had over 366, then you had, let's say, 367 people, 366 over, it is equal to 2. Therefore, you can guarantee that at least in all 366 boxes, one of them has 2 people in it, which means two people have the same birthday. And that's the generalized pigeonhole principle.
Pigeons are notoriously messy birds, which led computer scientist Edster Dijkstra to remove pigeons, along with their boxes, from the problem altogether. This resulted in what's called the purified pigeonhole principle. The purified pigeonhole principle states that if you have a non-empty, finite bag of numbers, the maximum value is going to be greater than or equal to the average value. Now, if we're going to go back to the example of pigeons, despite the removal, this essentially means that we can start working with partial pigeons. So even if we are to arrange the pigeons by taking various parts of each pigeon and putting them in various boxes, we're guaranteed that each box is going to have at least 10/9 pigeons. This is because we have 10 pigeons across 9 boxes, and if we were to divide them up evenly, that would leave 10/9 for each box, which is the minimum value. Therefore, the maximum has to be greater than or equal to, because if we move pigeon parts around, we can only increase the maximum. A particularly practical purpose for the purified pigeonhole principle pertains to people's placement on a test. Suppose the statistics are released for the 203 midterm. Let us define the class nerd as the person with the highest score. If the class mean average is 50%, the purified pigeonhole principle tells us that the class nerd scored greater than or equal to the class average of 50%. Our intuition may tell us that he or she scored more, but we can only guarantee greater than or equal to.
Thank you for watching this video, brought to you by Group B1 in EECS 203 at the University of Michigan. In summary, we talked about the pigeonhole principle, the generalized pigeonhole principle, and the purified pigeonhole principle. I hope this video helped you learn more about the logic behind objects and boxes. For more information about discrete mathematics, please visit www.notum.com. Thank you.